Hello, in this video I'm going to discuss present value ordinary annuity. We will know that the problem is an annuity problem if there is at least two cash flows, and the cash flows are number 1 equal in amount and number 2 equal in interval. So for this one, we'll be doing the ordinary annuity where the payment or collection happens at the end of the period. So given a 5-year timeline, the very first payment will happen at the end of year 1. And that payment will be payment from point 0 to point 1. And then for the payment at point 2, it will be payment from point 1 to point 2 and so on. Bottom line, the payment or collection will happen at the end of the period. Using the ordinary annuity setup, we will be computing the present value. So what you will do to compute the present value ordinary annuity is you will get each of your cash flows and then you will present value single sum them to point 0. So it will be like this. To appreciate, let's try solving some problems. Let's try this one. You are given an annuity of 200. So that's the regular payment or collection. You are given a rate of 10% compounded annually, time of 5 years, and you are tasked to compute the present value ordinary annuity. So before I answer, let me first illustrate the given. So you have a 5-year timeline. And then your annuity is 200. I wrote the cash flows at the end of each period because this is an ordinary annuity problem. And then the task is to compute the present value ordinary annuity. To compute the present value ordinary annuity, you need to present value single sum each of the cash flows that you have in the illustration. So you will present value single sum them to times 0. There is a formula to compute the present value ordinary annuity in one go, but let me first do it using the single sum formula. So what I will do is I will apply the single sum formula to each of the cash flows that I have. As discussed, to compute the present value single sum, you need the Now let's compute the present value of this one. So that's 200 times 1 plus rate. Rate is 10%. Number of compounding periods 1. Raised to negative 1 times 1. And then let's have the second one. To return that to times 0, you get 200. Then let's have the third one. And then the fourth. And lastly, what we will do now is get the sum of these 5. So if you add this 5, you will get 758.16. Now let's try solving this one using a formula. Alright, so let's try answering this problem again, but this time using the present value ordinary annuity formula, because earlier, we just applied the present value single sum to all of the cash flows that we have. And on the side, I have the answer from earlier. So for the formula of present value ordinary annuity, you need to get your annuity, multiply it by 1 minus 1 plus rate over number of compounding periods raised to negative compounding periods times t all over rate divided by number of compounding periods. So this is the formula to compute the present value ordinary annuity. Now let's try to apply this formula using the given. So in the given, the annuity is 200. Let's place that. And then 1 minus 1 plus the rate is 10%, so that's 0.10. Number of compounding periods, 1. Raised to negative 1 times 5 because t is 5 years. And then all over. So using your scientific calculator, you will determine that the present value ordinary annuity is 758.16. Maybe let's have one more before I end this video. Let's try this one. You are given an annuity of 400. The rate is 7% compounded semi-annually, and then time is 2 years. And then you are tasked to compute the present value ordinary annuity. So first, I'll do the timeline. Then the payment will happen every 6 months. So it will be placed here, 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 and here. It will be paid or collected at the end of the period because the problem is an ordinary annuity problem. So the task is to compute the present value ordinary annuity. To get that, you need to present value each of your cash flows. Again, to compute the present value single sum, you need the future value single sum times 1 plus rate over number of compounding periods raised to negative number of compounding periods times t. So let's start with this one. That's the future value single sum, 400. 1 plus rate. The rate is 7% since it is compounded semi-annually. We write 2 raised to negative 2 times, since this is only half a year, instead of writing 1, you write 0.5. Then for the second one, 400, 1 plus 7% divided by 2 raised to negative 2 times 1, because that's 1 year. Then we'll have this one, 400. We multiply the number of compounding periods by 1.5 because you will be returning for 1 year and half a year. And then the last one, so for this one, the time is 2 because you will be returning for 2 years. And then to compute the present value ordinary annuity, you need to get the sum of these 4. The answer is 1,469.23. Now let's try to solve the same problem, but this time using the present value ordinary annuity formula. And on the side, I place the answer from our single sum computations. So let's see if we will get the same amount using the formula. So in the problem, the annuity is 400. And then we write the others. Rate is 7%. Compounded semi-annually, so the number of compounding periods is 2. Raised to negative 2 times number of years, 2. All over. Rate is 0.07 over 2. Close. Then using your scientific calculator, you will determine that the answer is 1,469.23. Alright, so that's the present value ordinary annuity. In the next video, I'm going to talk about naman present value annuity due.